All right, today's objective, slope-intercept form. Let's go over some definitions first. Linear equation. Linear equation. An equation whose graph is a line. X-intercept. It's the x-coordinate of the point where the line crosses the x-axis. Y-intercept. This is the y-coordinate of the point where a line crosses the x-axis. Slope-intercept form. It's a linear equation written in the form y equals mx plus b, where y, as you can see, is by itself, it's isolated, and m is represented by the slope, x is your x-coordinate, and b is your y-intercept. And again, I broke down the pieces here at the bottom, where you have y equals mx plus b. Your x and your y are going to be your ordered pair, your x-coordinate or your y-coordinate. Your m is your slope, and the b is your y-intercept. Not the y-coordinate, but the y-intercept. And notice that by default, this is in addition. Now this form, if I had minus here, that would carry on the value of your y-intercept. So that's very important to know. All right, identifying the slope and y-intercept. So remember that in order to identify, as you can see with the previous slide, of how we have the equation set up, and it must be in the y equals mx plus b format. So let's look at number 1. Y equals negative 2x plus 1. So you can see here m, that's represented as the coefficient of this term. So that means that negative 2 is playing the role as your slope. Negative 2 is your m. And then positive 1, that is your b. That is your y-intercept. Number 2, y equals 7/6 of x minus 3/4. And again, here's your coefficient. So the m always is going to play the role as the coefficient of the x term. So that's how you know how you can identify your slope. So m is 7/6, and b, now here I have subtraction, so I know that my y-intercept is negative 3/4. Okay? Now, number 3, you notice that the given equation is not in slope-intercept form. So we're going to have to isolate y. So we definitely know how to do that. So we're going to have, add 6, then we're going to divide by 2, and once I simplify everything, I get y equals 3/2 of x plus 3. So you identify your slope and identify your b. So I have 3/2 is my slope, and positive 3 is my y-intercept, my b. So again, same thing with number 4. So let's go ahead and we're going to solve for y. Here I have the distributive property. So I get 30 minus 18 of x. So here I need to divide by 2. And I get y equals, well, 30 divided by negative 2 is negative 15. And negative 18 divided by negative 2 is positive 9x. So we're going to flip these around and get it in mx plus b form. Okay, so I can see here that my coefficient, my m, is 9, and my b, my y-intercept, is negative 15. And remember, when I keep saying coefficient, is because of our slope-intercept form. This m plays a role as the coefficient there. All right, write an equation in slope-intercept form. The first one, the directions say write the equation of the line when you're given your slope and your y-intercept. So the first one, I'm given m equals 3/8 and b is 6. So here's our slope-intercept form. So I'm just simply plugging in what they tell me, plugging it into the equation. And that is my equation of the line. M is positive 3/8. B is positive 6, so y equals 3/8 of x plus 6. Do not forget your x. That's a very common mistake, by forgetting the x. Now here on number 2, the information was just written out. So you know your slope is being represented by the m value, so that's negative 3. Y-intercept is negative 4, that's being represented by the b. So when I plug that in, I get y equals negative 3x minus 4. And that is my final answer for the equation of the line. Next one, it says now we're going to write the equations given the graph. So here I have a graph So I've written out some steps for you in order to obtain the equation of the line. So here I can see two points, so I've located them on this graph, and the ordered pairs are whole numbers, so that's of course important to do. So now the first thing we're going to do is find our slope. So from this point to this point, when I rise, how many units am I rising? 1, 2, 3. I rose 3 units up, and that's what I put here for my numerator. And how many units am I running? Well, I have to go left in order to go to this point here, because you're going from one point on the line to another point on the line. And so that means I went left 4 units. And remember, left is a negative direction. So that tells me that the value of my slope is negative 3/4. So that is my M. Next thing, I need to identify my y-intercept. Well, remember back when we said our y-intercept is a point that crosses on the line, that crosses the y-axis. So this one definitely is my y-intercept, which is at +2. So b equals +2. So let's plug in those values. Y equals negative 3/4 of x plus 2. Number 2. Again, let's just repeat the same process. So first thing we do is we find our slope. So how do we find the slope from a graph? We pick 2 points that are on that line. And here I identify those 2 whole number points. So here, how many units am I rising? Well, I'm rising 1 unit, and then I'm going over to the right 2 units. And I wrote that up here. So up and right are both positive directions, so I can see that I have a positive 1/2 slope. Number 2, identify the y-intercept. Here's my y-intercept, and I can see that it's intercepting the y-axis at +1, so b equals 1. When you plug everything in, y equals +1/2 of x plus 1. All right, next one, graphing equations. So now we're going to go vice versa. The other one, I gave you a graph and we obtained the equation. Now I'm giving you the equation, and now you're going to graph that. So the first step here, when you have y equals 3x minus 1, step 1, we're going to begin with the b, and we're going to plot the y-intercept. So my b is 0, -1. So here I have my -1 plotted. The next one is I take my slope, which is +3, right there in the equation. And so I'm using that rise over run form, because that's our relationship regarding the steepness of the line. So I have rise 3, and remember, to make this into a fraction, we put a whole number 1 underneath it. So 3/1. So we're going to use that slope in obtaining as far as other points on the graph. So here's my my b. So when I rise 3, 1, 2, 3, and I run 1. That's where that other point came in. From that point, rise 3, 1, 2, 3, and I run 1. I could keep going and obtaining as far as points on this line. And to get this point down here, you notice I rose, I went up, and I went right. Well, to get this point down here, you're just going to go opposite. You're going to go down, and you're going to go left, because a negative in a negative direction still give me a positive slope. So I go 1, 2, 3, and I go over 1. Okay? So then the last step is, of course, draw the lines through the points. Okay? So number 2, y equals -2/3 of x plus 2. Okay, so -2/3 is my slope, and +2 is my y-intercept. So remember, step 1, we begin with our b. We plot the y-intercept. So at 0, 2, this is my y-intercept. 2 on the y-axis. My slope is -2/3. So that tells me I can go down and I can go right, or I can go up and I can go left. But one of those directions must be negative because of the negative value of my slope. All right, so here I went up 1, 2, and I went over 3. 1, 2, 3. This point down here, 1, 2. So here I went down, so that's negative, so I must go positive. 1, 2, 3. And then you draw the lines through the points. done this one. I wonder what's going on. Let's say something's going on here. All right. Next one, identify the slope and y-intercept, and then we're going to graph it. So y equals 7 minus 3x. So again, on this one, be careful because this is not in y equals mx plus b. So make sure you get your x term first. So I went ahead and converted that. Y equals negative 3x. You see how it was negative here, and that's a positive 7. So that would be plus 7. So m equals negative 3. So again, rise to run relationship with a whole number. You're going to plop a 1 under it. So I know every time I'm running, I'm going to run 1. B is positive 7, so that's 0,7 on the y-axis. So here is where my y-intercept is. And then I'm going to take my slope, and that's how we obtain the other points on the graph. So if it's negative 3, remember you can go down and then right, or up and then left. Okay, so here to obtain this one, 1, 2, 3, I went up, but then I went left. So I use this set of directions. To obtain these points down here, I need to reverse that. 1, 2, 3, and then go right. 1, 2, 3, and go right. And I could keep doing that and obtain a nice line as far as see all the points on that line. Now let's look at number 2. Okay, in your packet on the example, it has a negative up on the very first initial. So make sure you change that to a +4 right here inside. Now this one on the work that you see in your packet, it already has that on there, okay? So this is the correct one that we're going to be using and the work that you can already see on your packet. So remember, this one is not in slope-intercept form, so we need to make sure we put that in there. So again, we need to distribute. So negative 2 times negative 3x is negative 6x. Negative 2 times positive 4 is negative 8. And then bring down the plus y equals 0. So remember, we're going to isolate y. So we're going to bring the x term over to the right-hand side. So when I add 6x, that adds up to 0. Negative 8 plus y comes down. And then the 6x comes over here on the right-hand side. From here, we're going to add 8 to both sides. This is where I get my y isolated. Okay? And then I have 6x plus 8. So here I can identify my m is positive 6. And you can see in rise to run relationship, I have a rise is 6, run is 1. My b, that's a positive 8. So an ordered pair form is 0,8. And here is my y-intercept already plotted for you. And to obtain the points, remember I used the slope. So from my b, 1, 2, 3, 4, 5, 6, and I run 1. Go down to the other way. So that one I went up and right. So guess what? I'm going to change that. Go down and left. 1, 2, 3, 4, 5, 6, and I run left 1. Okay, last one. Here I need to know if I'm given an ordered pair, this point, is this point on this particular line? Okay, so is the ordered pair of the graph is an ordered pair on the graph of the given equation? So remember, ordered pair form is x comma y. So what we do is we take this point, we plug it in. If it's a true statement, then I know it's on the line. If it's false, then it doesn't belong on that line. Okay? So when I plug in my x, which is negative 3, my x coordinate, I plug it in here to my x coordinate value. My y is positive 4, I plug it in here. Okay? So when I simplify this, negative 2 times negative 3 is positive 6. So does 4 equal 7? No, that's a false statement. So that means that when I'm actually graphing y equals negative 2x plus 1, negative 3 comma 4 is not a point on that line. It will not touch that ordered pair. Number 2, y equals negative 1/2 of x plus 2. Plug in your x coordinate, which is negative 6. Plug in your y, which is positive 5. So when I plug everything in, I get 5 equals, well, when I simplify, I do get a positive 5. So that is a true statement. Therefore, that is a solution. So that point is on that line. Okay? So now let's look at number 3. So here's my x and y. Okay? So when I plug in, my y is negative 1. My x is 0. And the coefficient here, remember, there's an understood 1 coefficient when you have that x by itself. Okay? So the x term is, the x coordinate is 0, and don't forget the b sitting on the end, minus 5/4. Okay? So 1 times 0 is 0. So here we have -1. Does that equal negative 5/4? And we definitely know that that is a false statement. It does not equal. Therefore, this point is not a solution. Okay? All right, number 4. Here I have both of my coordinates are 2's, so my y coordinate is +2. And then here, don't forget that my understood coefficient, I have a -1 sitting there. Okay, so when I plug in my x coordinate, I need to multiply that by the -1. All right, so 2, -1 times 2 is -2 plus 4. So here I do get -2, I mean +2 does equal +2. So this is a true statement. Therefore, this is a solution. So that point does lie on that line.